Now can you see my hand?
Yes.
Excellent. Wonderful. Okay. So here's the deal. If we're going to graph some parabolas, we know that if we have imaginary solutions, they don't touch the axis. We know that we could have a type of parabola that just comes down and touches it, and that has one solution. Okay, so that's where the discriminant equals 0. And then we have the type of parabola that crosses in two different places, and that's where the discriminant is positive. Well, here's the thing. We need to know where the vertex of each of these is. And we need a different way, a little more complete way to graph it. The good news is we already have all the tools we need to graph a parabola. And it's all contained right here in the Rosetta Stone of parabolas. Because in our Rosetta Stone of parabolas, this discriminant tells us how many solutions. This will tell us vertex information, and the whole thing will give us solutions. So let's put this thing to work. Y equals 3x squared plus 5x plus 2. Let's do that. All right. And so if we're going to do this, let's put this in the quadratic formula. A equals 3, B equals 5, C equals 2. So opposite of 5 plus or minus the square root of B squared, so 5 squared minus 4 times 3 times 2, all over 2 times 3. If I put all this together, oh gee, that is a discriminant of positive 1, which means I have 2 real solutions. All right, so that gives me negative 5 plus or minus the square root of 1, which is 1, all over 6. And at this point, if I finish solving it up, I get negative 4 over 6, or I get negative 6 over 6. So that gives me negative 2/3 and negative 1. Those are my two actual solutions right there. And if I try putting this on a graph, I know that because it's positive, it's going to open in the upwards direction. So I just have to graph. Here is 0, here is positive 1, here is negative 1. It crosses at negative 2/3, and it crosses at negative 1. So it's going to look like that. What I don't know is how low does it go? Where's this middle? How much sag in the bag there? Here we go. To do that, I need the vertex. Well, here's the good news with the vertex. Like I mentioned previously, opposite of b over 2a gives us the vertex. So we know that the vertex is negative 5/6, and we just got to find y. How do I find y if I know x? How do I find y if I know x?
You plug it back in.
Thank you. Okay. So I got 3 times negative 5/6 squared plus 5 times 5/6, negative 5/6 plus 2. So that's going to be 25 over 36. That's going to be 75 over 36 minus 150 over 36 plus 72 over 36. Now, all I did, folks, was get common denominators. I mean, not real shocking here. But the reason I got common denominators is so that I would very clearly get negative 3 over 36 or negative 1/12. And they say, well, I could put that in my calculator. Yes, you could have put it in your calculator. However, if you put it in your calculator, how many of you would have recognized the decimal that goes with negative 1/12? Probably not many. So our vertex is negative 5, 6, negative 5 twelfths. Let's think about this a minute. Oh, maybe we ought to show up on time. All right. Here we go. So why does this negative 5, 6 make sense if our cross at negative 2/3 and negative 1? Well, let's expand this. Let's like put a magnifying glass right here on this. If this is negative 2/3 and this is negative 1, and we know it crosses here and it crosses here, well, negative 2/3 is negative 4/6. Negative 1 is negative 6/6. So wouldn't it make sense that the vertex is going to be smack dab in the middle at negative 5/6, right down there, somewhere on that middle line? And negative 1/12 is not down very far. So our graph goes right through just like that. So I draw it back up here on this. It's going to go just right down here with my vertex at negative 5, 6, comma, negative 1/12. That is how you graph using the quadratic formula, graphing parabolas. There is a different way to graph parabolas, but that involves completing the square. And to be honest with you, you probably haven't done that yet in any of your classes or done it well. So that we're going to have to complete the square before we can come back and finish graphing using the completing the square method. So let's go ahead and let's do one more, since our team came and a few more have joined us here. Let's go with negative 6 here. So negative 6, that's going to make 5x here and x squared here. I want you to use the quadratic formula, and I want you to solve it. I want you to give me the vertex and give me a graph. Go. On your own piece of paper. Now, for those of you that did join us a little bit late, A equals 1, B equals 5, C equals negative 6. Our entire goal is to use the quadratic formula, opposite of B plus or minus square root B squared minus 4AC all over 2A, to tell us everything about graphing a parabola that we possibly can. So if I plug it in, negative 5 over 2 times negative 6, I already know that my vertex is going to happen at 5 over 12. 5 over 12. What I don't know is how high or how low it is yet. I'm going to have to plug that in. But I can keep trucking here and say 25 minus.
Wouldn't it be 2-1 since it's the A, not the C, for the bottom part?
Corin, good job. Yes, I put C in because I'm specialness and not in a good way. You're right. So it would be negative 5 halves, yes? That
Yep.
makes better sense. It also works better. Good job. Thank you for the catch. A, C, so here's 1 and here's negative 6. So in this case, negative 5 plus or minus the square root of. Now, this is 25. Now, two negatives make a positive. So plus 24, 49 all over 2. Well, obviously, we're going to have two real solutions. And so we have negative 5 plus or minus 7 all over 2. So that gives me 2 over 2. And that gives me negative 12 over 2. So that means I have solutions at 1 and -6. There we go. So 1 and 1, 2, 3, 4, 5, 6. Here and here. 1, -6. That's going to open up. Looks like this. We already know it's going to cross at -2.5. So we have vertex somewhere at -2.5. All I have to do is finish plugging it in. -5/2 squared plus 5 times -5/2 minus 6. So I got 25/4 minus 50/4 minus 24/4. Answer is -49/4. Does that make sense? Yeah, -49/4. And so -49/4 is 8 1/4, 8 1/4. -8 1/4. So I would go down 1, 2, 3, 4, 5, 6, 7, 8, and a little bit, and it's going to be way down here. So my final graph, 1, -6, 1, 2, 3, 4, 5, 6, 7, 8, and a little bit. Back here at -5, -5/2, comma, -49/4. And there we go. Just like that. Okay, guys, that's what you have to do. That is what is on slide 4 and 5. Now you'll notice there's no red arrows on 6 or 7. That's just another example to help you, okay? Just another example to help you. But that is due Monday. This other stuff is due Friday. All right, any questions? If not, I'm good and I'll catch you later.